Hello, everyone. Thank you very much for joining us today. Today, I'll be talking about the benefits of automated machine learning. We will take a look at what it takes to actually automate machine learning, take a look at our tool for AutoML, and also discuss the benefits for the business using AutoML in AI transformation. So first of all, it's clear right now that AI has become a central focus point for almost every company across all industries. The question that we are asking is, can every company actually implement AI? Are there enough qualified data scientists on the market to actually support that transformation? And can data science teams implement end-to-end solutions and do that fast enough? There are also many other considerations that come into play, especially in regulated environments, where it's very important also to be able to explain the models. The models have to be transparent and fair as well. So how can AutoML help us with those challenges? When we talk to our customers, there are several trends that we see across the industries. And one of the main one that is really a main challenge for most is time. Building machine learning models is a very complex and time-consuming process. Usually companies would implement models in a matter of months, going from the raw data to a deployable model. And some companies struggle with actual productization of the models, putting them in production, actually using them for the business. And given the large investments companies do in data science teams, they want to see a clear return on investment on AI projects. We also see that COVID accelerated digital transformations in many companies, and we see a lot of AI strategies that are now transferring from innovation projects to actual business value, core business projects which are driven by artificial intelligence. As I mentioned before, in regulated environments, especially, but in all companies, responsible AI is extremely important. Trust in machine learning is key. And companies are demanding deeper understanding and knowledge of their machine learning models. Regulators and auditors want to know exactly what the models are doing for each prediction, for each customer that is being affected by a process that involves machine learning. And in those environments, models must be explainable. We also see that companies want to have targeted solutions. So an end-to-end solution for specific use cases. They want to be able to really solve specific business problems end-to-end, driven by machine learning, and want to see those solutions customizable to their own needs. And part of modernization initiatives, we also see that companies are striving to connect large-scale IT-driven work with revenue-driven business projects. So really bridging the gap between what IT and data science teams are doing and really connecting them to the business users. In a lot of those points, we can help with automated machine learning, especially in the sense of time and the speed to actually get machine learning models into production, as well as in responsible AI, where machine learning interpretations can be automated as well. And in the general sense, making it easier for companies to actually bring machine learning models and AI projects into a state where they bring business value, and you can actually calculate the return on investment from the time that you invest in building models to what the models actually allow you to do in the company. So let's take a look at automated machine learning, what it actually is, and we will go into the details of what actually needs to be automated after that. So, of course, as it's clear from the name, the idea is that we take a machine learning pipeline and we automate tasks in that pipeline. So a lot of what goes into training a machine learning model can be automated, and AutoML is applied to real world problems. We also want to make sure that we cover the complete ML pipeline. That means from data, from raw data, up to the actual deployable model. So all of the stages that need to go in the middle of that are automated as well. One of the advantages of automated machine learning is the fact that it makes the solutions simpler, and it's possible to then include non-experts in the process of building machine learning solutions. Um, AutoML allows people with less knowledge about machine learning be an active participant in actually building the models, which allows companies to minimize their demand for expert data scientists. If AutoML is implemented in the right way, you would not have to really give up on the accuracy of the models. And many times we see that it's possible to build models which actually outperform hand design models. And of course, it's done in much faster fashion, and you can create many more models faster and have a simple solution that, that actually provides you a model that you can then use in production in your business use cases. I would like to go a little bit more into the details of what actually needs to be automated in each of the areas of data transformation, machine learning modeling, and model productization. After that overview, I would like to actually show you how we do that in H2O AI. So first of all, when we come to a new use case, we get a new data set, and we need to understand what we need to do with it and how we can actually model it. Usually what we would do is we visualize it first. And in order to really understand the distributions of the different columns in the data, see if there are outliers, analyze if there are anything that needs to be cleaned up, correlations, missing values, and so on, you need to visualize it in some way. And it's possible to automate that process of actually visualizing the data and analyzing the data so that you could have it in a matter of minutes instead of working on creating those visualizations from scratch every time that you get a new data set. Then we would go to data preprocessing. Practically, it means that we are cleaning up our existing data set so that the machine learning model could learn better from that. And that means some normalization of text columns, such as just making sure that all of the text is normalized into one singular form, because in the end, the machine learning model doesn't actually understand the semantics of your data, and we need to help it to actually understand that text with a capital letter is the same as text with a non-capital letter. We also want to make sure that all of our numeric variables are in the right format, and we want to normalize all the missing values. So all of those type of modifications that we do to our existing data without actually adding any additional columns is going into data preprocessing. And many of the tasks in data preprocessing again can be automated. This again is something that would take a data scientist quite a lot of time to actually go through all of the columns in their data. Sometimes the data sets are quite large, and really see how this data has to be processed and cleaned up for the machine learning model to learn the best from it. Then we may want to already before actually starting to train a machine learning model, do some feature selection, especially for large data sets. It would be important to select specific variables from our large data set and minimize the scale of the data. Feature selection is applied also after we actually add new columns with feature engineering. This process is actually something that can kind of go backwards and forwards as we go through the data transformation part. So we may actually start doing feature selection or feature engineering and go back to data preprocessing because we will notice that something was not done properly. Or maybe after we already add new features with feature engineering, we might actually want to go and visualize the data again, see that what we already preprocessed and engineered actually makes sense. Feature engineering is the most time-consuming part in the whole process. Feature engineering is using the data that we already have, using our raw data, and changing it so that we can add more information into our data set. So if, for example, we have a column for price and a column for quantity, but do not have a column for total cost, we may want to create a new one saying price times quantity, and therefore we will get a cost column. We may also want to process our dates to actually get out what year it is, month, day, or day of the year, or whether it's a holiday or not. All of this type of enrichment of the data so that you take what you already have and try to get more information from it is part of feature engineering. In reality, there are so many different ways to actually do feature engineering that this is so time consuming to actually try to select what would bring you the best value. And a lot of those methods are quite complex, and non-experts may really struggle with creating new features with advanced methods such as target encoding or dimensionality reduction. There are special feature engineering techniques for time series problems. You need to be able to also work with text and use natural language processing in order to get the most of your comments in the data or documents or anything like that. And then on top of that, of course, you may have other data types such as images or sound, and those also have their own feature engineering techniques that you would have to apply. We usually see that just for the data preparation part where you do this process from data visualization to feature engineering, this part may take really months to get into something that you can use really in production. In reality, for very difficult problems, this is a never-ending process, and some of the models companies are using are actually developed throughout years, trying to add more and more information into the data so the model would have more information to learn from. Now getting to the actual machine learning modeling part. So we have the data prepared, it has all the features that we would like to use, and now we want to actually start training a model. First of all, there are so many ML algorithms out there, and they are suitable for different tasks. And you may want to use a deep learning model or tree-based model, or even a combination of several models, creating an ensemble of different types. And again, this is something that data scientists would manually try different methods, compare them, and it's again something that takes a lot of time to do actually manually. And then on top of that, after you actually selected the type of models you would like to use, you would actually have to decide how you're going to actually define this model. So when we are talking about hyperparameters, we actually want to decide what would be the best way to define that specific model was selected. In a decision tree, how many layers of the decision tree we're going to have, what is going to be its depth, or how many layers we're going to have in a deep learning model. And there are many, many other things that need to be tuned to actually have a good machine learning model. And then afterwards, after we decided on the hyperparameters, we would also want to train the model itself, which means to actually adjust the parameters of the model itself to fit the data in the best way. So we would want to go from a stage where we have, let's say, a linear model that fits the data just a little bit to a linear model that would fit it better. And by changing the parameters that define, let's say, that red line, we actually tune the model. With much more complex model algorithms, of course, that process is more than just changing the two parameters that define that line. And again, this is something that takes time. Time is going to be a word that I'm going to say quite a lot during that presentation, as this is really the core advantage of AutoML is in time saving of what actually the process is, because the process is really complex. Then after we decided on that and we're tuning the model, what we really need to be aware of is that we can overdo it a little bit. And good AutoML tools know how to prevent overfitting. Overfitting happens when the model is managing to memorize the training data. So it actually fits it too well, and the results are just a little bit too good. The problem with that is that in reality, after you already trained the model, the new data that is going to come in and you would like to predict is not going to be really exactly the same as what you trained on. So you really want to make sure that your model knows how to handle new data. So it cannot be too accurate on the data it already seen, so that it would be general enough to handle new data. And there are different techniques to prevent that, and that has to be part of the automated machine learning tool capability to actually handle that. After we train the model and we know that it's good enough and we evaluated it, we have all the features in it, and we think that the results are good enough, it's very important to actually be able to explain what the model is doing. There are different reasons for wanting to have an explanation for the model. The most basic one is the fact that the data scientists themselves need to know whether the model actually makes sense. Sometimes we will get really good results, but actually the thing that the model actually learned in the essence is not what we wanted it to learn. It might have learned something using just one or two of the variables from the data that we didn't actually want it to learn. And in order to understand what the model actually does, we need to look at feature importance. We need to see how each individual feature actually behaves in the model and how it affects the predictions of the model. But we also want to see how the model itself behaves on different data, on different subsets of the data, if there are any interactions between the different features. And for most companies, what you would need to get out of a model to be able to explain each individual predictions are reason codes. In regulated environments and also in other, I think that now really everybody are aware that responsible AI is key for using machine learning in production. You should be able to really deep dive into your model and explain every single prediction. So if you are doing something like credit scoring or loan prediction, so if you should or should not give someone a loan, for example, you should be able to say why a specific person was given a loan and why a different person wasn't. And of course, fairness comes into play, and it's possible to analyze the model to see if it's fair or not. And there are many, many different techniques to do that. So for example, Shapley values are being used a lot in the industry. There are partial dependence plots, disparate impact analysis, what if analysis, sensitivity analysis. So there are really, really a lot of different ways to do that. And again, it's important that you would be able to do that in a matter of minutes and not spend, after you already developed a whole model, another few weeks just implementing those solutions that would help you explain the model. After we have the model, we explain it, we're happy with it, we want to actually use it in production. We then need to be able to answer questions after we actually deploy the model. And there are companies that really struggle with that transition from a data science team that are not necessarily a machine learning operations team to actually deploy the model in a way that it's fast enough, in a way that it's stable and always alive. It needs to be a real-time scoring of new data. And also models need to be monitored. You need to be able to say at every point in time whether your model is still accurate, still gives you the same results, the same scores it was giving you when you were training it. So if it's not, you should have a process to actually go and retrain the model. You also want to then see if the new model you retrained actually is better than your old model. So you should have some ways to actually compare the results of your model on new data. And you also have to have documentation for the model for regulatory reasons, but also for internal kind of flow of information. You need to know what changed between the models that you trained before and the new ones, and have some continuity, and it has to be well documented. Documentation of a machine learning process maybe is as time consuming as actually building the model, because you really need to go into the details of everything that you selected, everything that is part of that model, so that if anyone comes in and wants to change a small part of it, you would really need to go back and see exactly what was done. So that part is definitely something that, if could be automated, would be a great advantage, right? So if we summarize, we can see that this is just a subset of all the tasks that goes through a machine learning pipeline. Those are the main ones, but there are many others, such as leakage detection, drift detection, a lot of other things that need to be taken care of. And it's no surprise that even for a large data science team, taking a new use case in an environment where you have to also take care of deployment, of documentation, explanations, it takes months to actually go through all of that. AutoML, or automated machine learning, can really squeeze that time into a matter of days. And I would be showing you now how our tool actually does that in real-time demonstration. And we would see how all of those processes that if I would have to do that by hand would take me months to do, could actually be done even in minutes. But of course, with all the rest of the experimentation, actually finding the best model, putting into production, testing it, and so on, it might take days, but definitely not months using an AutoML tool. So let me switch to my driverless AI. Driverless AI is our automated machine learning platform. It is part of a larger platform I would mention after this presentation. And with this platform, driverless AI, I can do everything that I mentioned before in an automated way. I have two data sets in my driverless AI instance. This is a churn data set. That means that it's a data set that is for modeling whether someone is going to stay or leave a company. I have 14 columns in this data, And the first thing I would like to do is actually look at the data and see what I have inside. If I would want to do that in code, I would have to actually load the data and start looking at the different distributions and checking all the types. And I have everything already presented to me in driverless AI without me having to do anything. So I can see what kind of columns I have. I can see their types. I can see their statistics. I can see the distributions. So I can really see what my data looks like. And now I would like to actually go and visualize this data. So instead of me trying to think, okay, what kind of correlations I want to look at, and do I have outliers and so on, I can actually just with one click look at automatic visualizations which are created in driverless AI. And I can see, for example, the correlations between the different features and see that there are some correlated variables. I can see how strong the correlation is between the different variables. I also get an explanation on how that specific graph was created. I can download it. I can also create new ones if I would like from just a click-through kind of a user interface. So there is no code required to actually generate any of those visualizations. So this is great for just starting with a new use case, seeing how the data looks like, and making decisions about what else do I need to do with the data before I start modeling. All the part of data preprocessing actually happens automatically within driverless AI without me having to actually decide what to do with missing values or how to convert different data types or do any cleanup. It actually does that automatically and I don't have to go through it. And to start building a model, I can just go to predict and it brings me into my modeling screen where the only thing I would have to do is select what I want to predict. In this case, I want to predict if it's churn or not, meaning a customer will stay or not stay with this company. This is a telecom use case, so probably a phone provider. And that's it. And I can actually start modeling. I would also provide a test data set so I can see the results of my model also on data that it's not being trained on. I can also select what I would like to actually optimize. I can select accuracy or AUC or any other metric that I would like. Let's go with accuracy for this one for simplicity reasons. And of course, I have a lot of different settings that I can play with. There are expert settings to really go into the depth of features and models and a lot of things that can be handpicked by the data scientist. But as the name suggests, those settings are for experts, meaning that when I use the tool, and I use it a lot, I do go into specific tabs and actually decide on different things that I would like to change and enhance in the tool. But it is not something that is necessary for someone who is not an expert to actually go and change anything. So I can actually start modeling without any knowledge about how to build the decision tree or a light GBM, or how to actually ensemble models, or how to create any of the feature engineering that is going to be created automatically for me. So let me launch an experiment and see what actually happens. We can see that right from the start, it's preparing the data, detecting the schema and checking different column types. So all of the data prep is actually done for me. It's checking for leakage and for drift. So I can see that actually my data is suitable for modeling, and immediately it starts to train the first model. During that training, it will also try to create a lot of new features using different techniques for feature engineering. So we can see right from the start that it already created some interactions and some target encoding and so on. So from that perspective, it will try to bring in more and more different features throughout the process of finding the best model automatically. It would also try a lot of different algorithms for machine learning, and it would combine different sets of features, both the original ones from an original data set and also a lot of different engineered features that it created automatically. And then try to improve the performance of my model. So I'm trying to improve my accuracy. So it would go from the first model it tried with a certain amount of features and a certain algorithm, and would try another one, which would be different and would have a different set of features until it will either go through all of the iterations that I decided to give it, all the time that I decided to give it, and or until it actually finds the best model and would not be able to improve anymore. So we are 1 minute, almost 2 minutes into the process of building a model. And in those 2 minutes, out of the 14 columns that we started with, we can see that it builds a model with 47 and already tried 5 different models and feature combinations in those 2 minutes alone. Just imagining doing that by hand, I think that only that process, only those 2 minutes, would definitely take about a week or two to implement, comparing all the models and trying all the different combinations of features and calculating them, making sure that all of that is done correctly. And as the process will move on, we would see more and more complex features created, and after the features are created, some of them are being selected and so on. Now I have that model already trained, and I will jump to a finished model. I can see here in my experiment page that a model that I trained before was completed in 15 minutes, and we'll see what it was actually doing. So by the end of those 15 minutes, I have a completed model that I can already deploy. So from a start where I had the raw data with absolutely no feature engineering, no cleaning, just took it as it was, and in 15 minutes, I have a model I can deploy into production. In that time, in those 15 minutes, the driverless AI created 301 features out of the 14 that we gave it in the beginning. And it trained many, many different models. It trained 79 models for feature tuning and 54 models for feature evolution. And it's just an incredible way, an incredibly fast way to actually get into results, knowing that you are using a software that is really designed to prevent overfitting, that has all the expert data scientists of H2AI developing the solutions, the algorithms, and the functions in state-of-the-art ways, so you can really trust the solution. And of course, as I mentioned, that takes time to actually go and document all of that. I actually get an automatically generated documentation in a Word format that really tells me exactly what has happened during that training and what features I used and why I selected what, and all the analysis of the data. It all is there for in the Autodoc. And I can also see the machine learning interpretation for that model, which was also all generated automatically. So I can see the feature importance. I can see what actually drove my model to decide if someone is going to leave or not. So I know that if someone has auto-renew, their chances of leaving are lower. And I can also see if certain features have an effect on predictions. So I can see if, for example, if gender affects my prediction on the model, and I see that actually the difference between female and male is not large, so so that's good. My model is fair with respect to gender, and there are a lot of other methods that more advanced methods that we might want to look at to actually see how my model was trained and how it actually predicts that specific target, right? So here, for example, I have a simple decision tree that shows me how the model decided to go from how the model actually decides whether someone is going to leave or not, and what kind of features and combination of features actually drive that decision. So there are a lot of different, a lot of functions, a lot of functionality that is embedded in driverless AI for automated machine learning. And you can really go from raw data and into feature engineering and model selection and tuning and assembling, all through to model productization, explanations, documentation, and many more. So, so this is really an end-to-end solution for AutoML, and we could really see that it's much faster than going through the complex process manually. Let me go back to my presentation and actually see what else we can offer from our company beyond the AutoML functionality itself. So as of course we discussed, feature transformation, machine learning, modeling, explainable AI are all part of our AutoML solution. And you could also build, as I was showing, those models in driverless AI and deploy them into production. But we also have other components on our platform which would also allow you to do the machine learning operations, deploying models into Kubernetes with one click, monitoring and detecting shift and drift, and also a functionality or a capability to develop applications built on top of our machine learning models for really bringing it to the business users, so the business users could get the best and the most from your modeling efforts. And we have a low-code app development framework with an app store that the customers can use to really use those targeted solutions that solve specific business use cases. That tool is called H2AI Hybrid Cloud. And you can actually try it out for free. And Ivan would be posting a link to that environment where you could try it out. And the end-to-end process, not just making the models themselves, but also bridging the gap and having business users really participate in building the solution is something that we see as key going forward in AI adoption and transformation. So going from a situation where you have a very expensive, large data science team that works for long hours to produce a model that is difficult to deploy, to manage in production, really long timelines for getting a use case out to the business users, but also not actually having any connection, any easy way to bring that solution to the business users. In order to solve that, we developed H2AI Hybrid Cloud so that fewer resources could actually produce many more models, connecting different people on the team, not just expert data scientists, data engineers, and developers, to really work together on solutions which are then could rapidly be put in the hands of business users, and that business users can really go and use the models right from the hands of the data scientists and developers. To summarize, automated machine learning helps us, first of all, obviously with time and speed to actually get models into production, I think it was quite clear the process is very, very complex. Manually creating models is just a very time-consuming process, and we want to be able to do that faster. We want to be able to experiment faster, and we want to be able to create production-ready models faster. We also believe that AutoML, which is done right, is creating models which are very accurate and could be better than the models which are handwritten by data scientists. We believe that part of an AutoML solution has to be also responsible AI, being able to trust and explain the models. AutoML will help you scale, both scaling your production of machine learning models, scale your teams, and scale your solutions using a platform that can answer a lot of different business needs in one platform. And of course, the flexibility of using the software on cloud, on premise, bringing in different data from different sources, and making sure that your solutions are tailor-made for the business use cases that you need to solve. So you can go ahead and get started with trying H2A hybrid cloud. I showed you just a small part of the whole solution, which is driverless AI, solving the actual AutoML part of it. But in H2A hybrid cloud, you could also try our machine learning operations solution. You can try different applications that we created to get you started, to get you kind of to understand what the art of the possible when creating AI applications for the business. And you could try it out and see if this could be a solution for your business as well. Thank you very much. And we have a bit of time for questions.
Great, thanks, Lena. Yes, we did receive a few questions. So the first one is, what type of machine learning problems is the H2O platform suitable for?
Great question. So we work with companies in a lot of different industries. So we solve use cases from a variety of kind of machine learning problems. From a technical point of view, we solve machine learning problems which are supervised machine learning and also unsupervised machine learning problems. So you could actually do anything from forecasting, classification type of use cases like we saw today with the churn model. You could do forecasting for time series. You could also solve problems involving natural language processing. We have showed real great success with image processing type of use cases. And you could also try unsupervised learning to detect outliers, create clusters, and so on. So it's very not really industry specific, a broad use case kind of coverage with our platform.
Great, thanks, Lena. How can I customize the solutions in your platform?
So there are many ways for customization. If we go kind of from the end of it, so the application platform where you can actually develop your own applications is probably the best way to customize a solution. It's very easy to write applications with our framework. It's Python only. And you can do really, really advanced things in it. So this way we can really bring specific solutions for our customers. And we believe that customers themselves, their developers, could do that by themselves, or we could help you out and build the solutions for you. But we also have a lot of customization in the automated machine learning platform in driverless AI. You can bring your own code into the platform and actually introduce algorithms which we do not have inside of the platform. You can introduce feature engineering techniques or even explanations. And we also have a repository of those additional code, which is all open, and you can also reuse a lot of the code that we already published for customizing and enriching the capability of driverless AI.
Okay, thanks, Lena. What methods do you use for explaining the models?
So I mentioned several, and we also could see it in the demonstration. We have sensitivity analysis that allows you to really go through a deep analysis of the model from perspective of kind of what if filtering and seeing how the model behaves on simulated data. We have disparate impact analysis that helps with fairness analysis. We also have Shapley values and Shapley plots. We have K-Lime analysis. We have partial dependence plots, surrogate models for explaining the model with a more simpler model, as we saw with the decision tree. And you could add more. So if there is something that you would like to have that is not part of the solution, you can actually write a custom addition to driverless AI, or again, we could help you with that as well and write something for you.
Okay, we do have a few other technical questions. On which infrastructure are you running the machine learning algorithms? And also, where do you store the data that we upload to train models on top?
Great. So right now, the whole solution is designed to be deployed in your environment, so in the customer side environment. We are not yet in a position of providing a software as a service solution, but we are planning for that. And so practically, you would install the software on your environment. What is great is that it's really environment agnostic. So if you want to install it on premise, you could. If you would like to use one of the clouds, you could do that as well. And therefore, you would store the data wherever you decide to store the data. Driverless AI is specifically optimized to run on GPUs. So if you can use an environment either on the cloud or on premise that has GPUs in it, you would really get more from the tool, and it will be much faster. The environment that I was showing today had one GPU in it, so of course it made the training faster. But that's so it's your decision how much power you want to give it. And if you would install it on a smaller system, it would be slower, but it would still work. So it's really up to the infrastructure is really up to you.
Okay. Which language is available for NLP? And is it possible to solve multi-language problems?
Yes. So we decided as a strategy to not really focus on one specific language for natural language processing, but use methods that are language agnostic. So all of the feature engineering that comes in driverless AI, you could use it on any language. And on top of that, we have PyTorch models, BERT models that are multilingual. So actually, you would be able to train also a deep learning model inside of driverless AI using the multilingual pre-trained models. So this would also work for many languages. If there is something specific you want to add that is specific to your language, so let's say you want to do some pre-processing, which is really specific for it, it's possible to add it as a custom add-on into driverless AI, and it would be incorporated natively into the system.
Great, thanks, Lena. So one last question, how can we learn more about the solution?
So first of all, of course, try it out. I think really just trying out the solution would give you a good idea of what it has and how it works. We have public documentation for all of our products, so you can go and read about our products at docs.h2o.ai. If you would like to know more about our business solutions and case studies, please visit our website, H2O.ai. And of course, you can contact us. So please either contact us directly, contact myself or Ivan, but you could also contact us at sales at h2o.ai.
Great. Thank you, Lena, for taking the time today. And thank you to everyone who joined us. We would love to get your feedback on this webinar and the next topics you would like us to cover, so please answer the quick survey that will show up after we close the event. We hope you enjoyed the presentation. Stay tuned for upcoming events and have a great day.
Thank you.
Thank you. Bye.